Hello guys, my name is Krish Naik and welcome to my YouTube channel. So guys, we are going to continue the 7-day series for the end-to-end machine learning projects with CI/CD pipelines and deployment. Obviously, we'll be using MLOps as we go ahead. But here in this particular video, we will be talking about data transformation. Already in our previous video, we had implemented data ingestion. Again, what was the main purpose of the data ingestion was that we probably read our data set from some kind of source, and then we did our train test split. So here was the entire code. We did our train test split and we saved this inside one artifact folder, right, with respect to all the data set. So this was with respect to data ingestion. Now if I probably go and see my train.csv and test.csv, I have all these particular data points. But one thing that you can probably observe over here is that, right, I have so many different kind of features like categorical features, numerical features and all. So with respect to categorical, numerical features, what kind of data transformation you need to do, and that is what we are going to discuss in this specific video, right? So here I have my data transformation. Now I'm going to write my entire code over here. The main purpose of the data transformation is basically to do feature engineering plus data cleaning. If I really want to change some of my data set, convert my categorical features into a numerical features, I can definitely do it from here. Now let's go ahead and let's write this code. Again guys, if you have not seen this particular playlist, the entire playlist link will be given in the description. All I want from you all side is that now less number of people are basically seeing it. So please make sure that you watch this entire series. It is quite important. You will learn any kind of projects once we do this implementation. It will become very easy for you. Okay. So let me go ahead and first of all, I will go and import sys. So first I will be requiring this, and then from data class is I am going to import data class. The reason why I'm doing this, I'll let you know. Okay. Along with this, I will also be requiring numpy as np. So see, I'm focusing on basically doing data transformation. That basically means any data set that I have, I will probably be using all the transformation technique. If there is a categorical feature, if there is a numerical feature, if I want to handle missing values, everything will be handled over here. So here I have import numpy as np. And then we go ahead with the next step that I'm going to import pandas as pd. So pandas as pd, pd. Okay. So this is the problem, sometime when you start using too much of help from the VS Code itself, right? Then along with this, I'm going to import from sklearn.compose. I'm going to import column transformer. Now see why I'm importing this, because if you remember in my notebook file for the model training purpose, what all things we specifically did, right? If we go over here, we used caller transformer, you used one hot encoder, we used standard scaler. So all these things we are also going to use again in this data transformation technique one by one. So I'm going to import column transformer. This column transformer is basically used to create the pipeline, right? So first of all, I may be doing one hot encoding, I may be doing standard scaling. So if I really want to create in the form of pipeline, I can basically use this column transformer library. Okay. And then let's say if I have some missing values, so for that I will be using sklearn.imputer. Okay, so here you'll be able to see .impute. .impute, I'll be importing something called a simple imputer. And again, different imputation techniques you can basically do. Again, the main thing is that I'm just trying to show you some ways. All the other ways you can definitely explore in that. Okay, then what I will do, I will also make sure that I implement the pipeline. So for that, I will be importing the pipeline also. Okay, so importing the pipeline, and finally from sklearn.preprocessing, since these two libraries will be super important. Okay, which libraries? That is import one hot encoder, and along with this we'll also be using standard scaler. Okay, standard scaler. Now just let me know why one hot encoder and standard scaler is used. Try to write in the description of this particular video. Now these are some of the libraries that I will be using in this specific file. Now coming to the next one, the first thing that I will be requiring is exception, right? So from exception, because I need to do the exception handling over here in data transformation also, right? So from exception, I'm going to import my custom exception. Along with this, I'm also going to import my logger, source.logger. Okay, and I'm going to import my logging over here, and then Yeah, I think this two will be fine. If there is anything most to be imported, I will probably go ahead and write the code later on. Okay. Now, as usual, in the data ingestion, right, we had also created a data ingestion config. Now, this data ingestion config is just like providing all the input things that is required for this data ingestion component. Okay. Now, similarly for data transformation also, I will try to create that. So over here, I will write class data transformation config. Okay. Now this config, what it will give me any path that I will probably be requiring, any inputs I may probably require for my data and transformation component itself, right? So here what I'm going to do, I will create my pre-processor. I will talk about this, why I'm creating this. So this will be my pre-processor object file path. Okay. So let's say that I want to probably create any models, right? And I want to probably save that into a pickle file. So for that, I require any one kind of path, right? So I will write os.path. Okay. I did not import OS. So let me go ahead and import OS. Okay. Import OS. I will be requiring this. Okay. Perfect. Now here I will write os.path.join. And again, I will try to get my artifact folder. Okay. And let's say if I'm creating any pipeline pickle file, I will name that as preprocessor dot pickle file. Right now, see, I've just created preprocessor pickle file. You can also create model file, but this is just an example to show you in data transformation config what exactly you want. Okay, you basically just want to give the input to the data transformation component. Okay, and now here I will again use data class. I hope everybody knows the feature of data class. Please do let me know in the comment section why data class is basically required. Okay, already I had told in my previous video, but this is just to check your knowledge, because in an interview they may ask you. Now let me go ahead and write my data transformation. Okay, now with respect to this data transformation class, now this is the config, or this is the input that I will probably be giving over here. Now first, obviously as usual, I will be writing def underscore init underscore, and this will be with self, and here I'll be initializing self dot. Okay, and I will write data transformation underscore config. All right, this will be initialized to what? This will be initialized to this particular class over here, right? So in short, what will happen inside this data transformation config, I will be having this particular variable. Okay, so that is the first parameter I will be probably requiring over here in the data transformation config. Okay, now what we will do is that we will write a new function inside this particular class, which is basically called as get transformer, data transformer object. Okay, so get data transformer underscore object. Okay, and here I'm going to use the self. Okay, so these are there. Over here what I will be doing is that the reason I'm creating this function, okay, this is just to create all my pickle files, which will basically be responsible in converting your categorical features into numerical, or categorical into numerical, if you want to probably perform standard scalar and all. Okay, so here I will write try, and this will basically be inside this try. Okay, so here I will go ahead and write try, and this will basically be pass, and again accept, and here also what we'll do, we'll just write it as pass. So I'm just going to write the code with respect to the try and catch block over here. Now as usual, if I probably try to open the train.csv, you will be able to see what are the numerical features and categorical features that I have, right? And obviously that I specifically performed in the EDA also, and I got the information about that, right? We understood that what all features were there. Again, I'm telling you guys, if you did not see the previous part, you really need to see it. Otherwise, you will not be able to understand, okay? So over here, first of all, I will take all my numerical features. I have already made the distinction between the numerical features. So here will be my numerical features over here, okay? So this will basically be my numerical feature. In the numerical feature, I have write score and reading score, and probably in the categorical features, I have all the remaining features. So here, let me go and use this categorical features over here. So this is nothing but gender, race, ethnicity, parental level of education, lunch, and test preparation course. Now, what we will do is that we will do two important things. Okay, one is, first of all, create a pipeline. With respect to the pipeline, we also saw, guys, there are some missing values. Okay, so we need to handle those missing values. So for that, if I probably try to create my numerical pipeline, okay, and this numerical pipeline I will initialize to pipeline. Okay, now see, this steps is super important. Okay, and this is the most important thing with respect to this. So here I will be writing 2 steps. Okay, the first step over here will be my imputer. Imputer basically means this will be responsible in handling my missing values. So imputer, and here I will be initializing my sample imputer, and the strategy, okay, will be used as median, because there are some outliers which we also saw in the EDA, right? So if in the EDA we also saw in some of the numerical features there were definitely a lot of outliers, so we are basically using median. Okay, so this is done with respect to the handling the missing values. Now after this, what we'll do, we'll also try to handle standard scalar. So for this I will create another variable like scalar. Okay, so just a second. So this will basically be scalar, and inside this scalar I will just try to initialize standard scalar. Now what exactly is happening over here? We have created a pipeline which is doing 2 important things. One is handling the missing values with this particular strategy like median, and the second one is basically doing the standard scaling. Okay, and this pipeline needs to run on the training data set. Okay, like fit underscore transform on the training data set, and we just do transform on the test data set. Now similarly, I will go and create my categorical pipeline, right? So this will be my categorical pipeline. And let's say if I get a numerical feature over here, sorry, in categorical pipeline, obviously what I will get, I will basically get all my categorical variables. So here I will just define it. So let's go ahead and probably define our categorical pipeline. Now inside this also, we need to handle multiple steps. Like let's say if there are missing values in categorical features, then how do we handle that? And for handling the categorical feature, converting into a numerical value, how should we basically handle that? You know, all those things we will probably try to do. So inside this, what we are going to do, again, this was a pipeline. So let's see why this pipeline is not coming. Pipeline. Okay, no worries. So here it is. Okay, this was the function over here. Okay, now fine. With respect to the pipeline, here I'm going to basically create my steps, and again my steps will basically be having multiple steps altogether. So here I will be writing steps. Okay, the first step, again, to handle the numerical feature, sorry, to handle the missing values. So here I will be creating imputer, and usually what we do, we basically use a simple imputer, and the strategy that we can probably use over here, strategy that we can strategy. Please make sure that you write the spelling well, otherwise strategy. Okay, strategy. Now this looks fine. Okay, strategy. Strategy, it will be nothing but it will be most underscore frequent. Okay, so that basically means I'm just going to replace all the missing values with the help of mode. Okay, now this was with respect to the steps. The first step, I'm going to probably apply this in my pipeline. The second thing, obviously I'm going to use my one hot encoder. And again, here you can also use target guided encoder or whatever encoder you do, because in the EDA we have seen that there are very less number of categories in every categorical variable. So here we are just going to use one hot encoder and we are going to initialize it. Okay, and then coming to the third one, if I probably talk about the third one over here, I also have to do the standard scaling. Okay, and I think if you don't do also, it is fine, but let's go ahead and do the standard scaling so that I show you many things. Okay, over here. So done. This is all the techniques that we are going to perform in the categorical pipeline. Okay, the first thing first, what we are going to do over here is that we're going to apply the imputer pipeline, then one hot encoding, then scalar. Okay, so here missing values is getting handled for the categorical features, then one hot encoding is basically handled for the one hot encoder, and then you are basically doing it as scaling. Now I will also go ahead and write my logging. Okay, so logging.info, and here I can go and basically write categorical columns encoding. Okay, encoding completed, right? So here I can write this logging info, and similarly I can copy this and I can say logging.info, and here also I will talk about the numerical columns, and here I will not say encoding but at least standard scaling I will basically write. Okay, completed. Now here you can basically see both of these things we have basically done. Now all we need to do is that combine this numerical pipeline with this categorical pipeline together. So for that only we will be using column transformer. So for this we'll be using preprocessor. Preprocessor will be my variable, and here I'm going to use column transformer, and this column transformer will be having the combination of two things. Okay, one is the numerical pipeline, okay, numerical pipeline, and the second one is something called as numerical pipeline comma numerical underscore columns. Okay, so here see what we are doing. This is what is the numerical pipeline that we are giving over here. Okay, and for what variables we are specifically doing this, we are doing it for the numerical columns. Okay, so inside this we first of all give our pipeline name, then what pipeline it is, and then our columns. Similarly over here the next step will basically be my categorical pipeline, right? So this will be like cat underscore pipelines. This will basically be my name, and here I'm going to basically give my categorical pipeline, and then this will basically be my categorical columns. So comma categorical columns. So yes, both of them have been given inside this column transformer. Again, understand what all things we did. We created a numerical pipeline which is doing two tasks, right? That is imputer and scaler. Okay, that is handling the missing values and performing standard scaler. Then we have categorical pipeline that is performing imputer, one-hot encoding and standard scaling. And then we did the logging.info. Then we finally created, I'll not write this over here right now. Let me just go and give simple columns, right? Like this. I will just go and give this logging statement, right? Just to display our categorical and numerical feature. And then here I'm creating a column transformer, which is the combination of numerical pipeline and categorical pipeline. Okay. So all these things is done. And finally, what we do after this, we come outside and we return the preprocessor. Okay. Now, once we return the preprocessor, that basically means we are returning this entire thing with respect to whatever things we have done over here. Now, in the except block, what I can do, again, it is very much simple. I will write exception as E, and I will try to raise my custom exception, right? And this we have done it multiple times. So I'll go ahead and write raise custom exception with E comma sys. Done. Perfect. So we have actually created the get data transformer object. The main aim of this particular definition of this particular function is to, I will also write the definition. This function is responsible for data transformation based on the different types of data. Okay. So perfect. I've done this, and this is very much good. We are going in a very good way. We are able to complete all these things and all. Okay. So finally, you can see get data transformer object. Now let's start our data transformation techniques. Okay. So this is where I will start my function. So this will be my another function, which is like definition, initiate. I will just write it as initiate data transformation. That basically means I'm starting my data transformation inside this function. Okay. And here again, I will be using self, and then I will give my train underscore path. Okay. Train underscore path, and this will basically be my test underscore path. So training path and test path. And you know from where you are getting this, you are getting this from the data ingestion, right? And done. Over here, again, I will be writing try pass. Then I will go ahead and write accept pass. Okay. As usual. Okay. Now fun, this is good. Now let's go and read our training data set. So I'll write train underscore df is nothing but since we have already imported pandas, so I will write pd dot read underscore csv with my training path. Okay, then I can go ahead and write my test underscore df, which is basically pd dot read underscore csv. Okay, so this will basically be my test path. Now here I can basically write my logging.info, so that you'll be able to log all the details, the train and test, read train and test data. I will just write like read train and test data completed. Done. So initially we'll go ahead and read this. Now the next step what we are going to basically do over here is that after this I will write one more logging.info, and I'll write that obtaining pre-processing object. Okay, so done. This is done. With respect to this, I will be reading all my preprocessor object. So for that, I will just write preprocessor. Now, what is this preprocessor object? Whatever object I created on top, right? This one, this preprocessor. I'll try to call this. So this will be nothing but here I will write self.get transformer object, right? So here I will be getting this particular object over here. Perfect. Now I will go and create my target column just to make sure that my target column name. So this will be my target column name. My target column name is nothing but math_score. So if you see the data set over here, so this is my training data set. There is something called as math_score. So this data set will be my target column. Okay. Numerical column, you basically know what is my numerical column. This is nothing but writing underscore and reading underscore. So I will copy this same thing for my numerical column. So this will be my target. This will be my numerical columns. And now what I will be doing is that you can basically check out with respect to continuous values, numerical values. Again, categorical features also you can make sure that you can basically write it in a way. Okay. Now this is fine. Perfect till here. Now what I'm going to do, I will say input underscore feature underscore train underscore df. Here I will write train underscore df dot drop. I'm just going to drop the columns. Which column that is? That is nothing but my target column name. Okay, from the input feature, and I will just write axis is equal to 1. So guys, one final thing that I'm going to do over here you could see that we have created this pre-processing object, right? And you know that this can be converted into a pickle file. It needs to be converted into a pickle file. So for this, we have not converted anywhere, but we have taken the path, right? The path is basically given somewhere over here in the data transformation config, right? Like pre-processor pickle. So what we'll do, we'll go ahead and save this. We'll save this pickle file in the same location. So over here to save it, I will just do it after this. So here I will just create a function which is called as save underscore object. Okay. And I will just give this file two parameters. One is file object or file path. Okay. These two variables I will give. I will write it as self dot data transformation config. So this will be the same thing, data transformation config. This entire thing I will be giving this. Okay. Self dot data transformation config dot pre-processing object file. This will be my first parameter with respect to the file path. Okay. In short, I'm having that entire file path like artifacts pre-processing pickle, right? So this is what is the file path over here, right? Something like this. So this will be my first path and the first parameter, and the second parameter will basically be my object. Okay. So this will be pre-processing underscore obj. Okay. So this is my object that I really want to save it now, because this is the what I has the model with respect to all the transformation. Now where do we write this function save object? Now to make your work very much easier, I told you, right, we are going to basically use utils, right? So utils is one place inside the source, right? So if you probably just go and minimize this source, inside this source you have something called as utils. And I told you that utils will have all the common things that we are going to probably trying to import or use, right? The common functionalities which the entire project can use. So here also I will write import OS. Okay. And here I will go ahead and write import sys for my exception handling. Import numpy as np. Import pandas as npd. Okay. So np import pandas as pd. Okay. Oops, I hate this now. I'm going to stop this now. Import pandas as pd. Okay. And if I want to probably do train test split, I can also write it over here. See, the train test split initially in data ingestion was written over here. Instead, I could have written over here and called that particular function over here itself, right? So it is up to you. Okay. If you want to make your code very much cleaner, then we will do this. Now what I will do, I will just create this function called as save path. Okay. So okay, I will also make sure that from src dot exception Okay, import custom exception. Okay, now perfect. Now I have defined this save object function over here. This is taking the file path and obj. It will basically take the file path, or it will make a directory like this. If it already exists, it is going to do it. Then we are going to open the file path in the write byte mode, and we are going to do the dill.dump. Okay, so what is this dill? This is also another library which will actually help us to create the pickle file. Okay, right now dill is not there, so go ahead and import over here. So like dill. Okay, and I will just go into the terminal. Okay, and probably install pip install -r requirement.txt, just to make sure that the dill is getting imported or installed. So yes, successfully installed dill. This is good. Now if I go and see import dill, this will be available. So this will be dill.dump. Dump. When we dump this will be saved in the specific file path. Okay, so in short, with the help of this code, what we are doing is that in the data transformation, we are saving this pickle name in the hard disk. Okay, now in order to use this, all I will be doing again, I'll just import from source, or I can basically import something like this. Let me just write. I think it is inside the source itself, right? So okay, no worries. From source.utils import from source.utils import save underscore object. Perfect. Now this save underscore object, we can call it over here, and this is just used for saving the pickle file. Okay, good. We have done it almost. Data transformation and data. So in data transformation, we are handling the categorical values, numerical values. We are creating this entire pickle file, doing everything. Okay, now it's time we go into the data ingestion part. I had already written this code. Okay, now what I will do, I will also import from here, from sklearn, from source. I'm going to, from source dot data transformation, I think it is source, from source dot components dot data transformation. I'm going to import data transformation, and along with this I will also import data transformation config. Okay, I'll import data transformation config just to check everything is working fine or not. Okay, and finally over here, when I do object.initiate data ingestion, then I will be returning two values. One is train data and test data. So here, let me go ahead and write train underscore data, comma, test underscore data. And this will what I will be basically getting. Now after this, all I will be doing is that I can create I can probably say in the data transformation, right? I can probably just call this data transformation, and with respect to data transformation, I can probably call this all the functions that I have. Okay, so here I will again go into my data ingestion, and let me go ahead and write data underscore transformation. This will be nothing but data transformation. Okay, once I initialize this, you'll be able to see that it will call this self dot transformation function. Then what I'll do, I will just call this initiate data transformation. So here, if I write data underscore transformation dot initiate data transformation, done. Most of the execution will happen inside this data transformation. What we need to give, our train data and our test data. Okay, and that is what we need to give. I'm just trying to see whether it will be running or not. I'll get some errors. Let's see what all errors will be getting. Fine, we are good. Now let's execute this code. Okay, so what is happening? We have combined data ingestion, and then after that we have combined data transformation. Okay, oh, hope so it works. I've continuously written the code now. Now usually, see, when we are writing in the real world scenario, right, we will be facing some kind of issues. So here I will go ahead and write Python source data ingestion.py. Okay, I have to basically go ahead and write Python source components / data ingestion.py. So the execution has started. Let's see whether this will get executed perfectly or not. At the end of the day, I should be able to see some pickle file over here. So now if I go and see, okay, pickle file is not get created. Let me see why it has not got created. So refresh. Great. Execution has happened successfully. Now let's see. Something is there. Let's see the logs. Ingestion of the data is completed. Okay, fine. After the ingestion of the data is completed, let's see in the data transformation. So guys, what I see from the logs, I'm not able to see the error. The reason is that because I did not write this except block. So what I will do over here, I will say except exception as E, and here I will just raise my custom exception. Now I think we will at least be able to see the error, what error we are able to get. Okay, and here I'm going to give E comma sys. This is fine. Okay, now let me do one thing. Let me again execute this. Now I think you'll be able to see the error. See, the error is coming as occurred in this is 86. Init got an unexpected argument strategy. Okay, fine. I understood what is the problem. So in the data transformation, you'll be seeing that this spelling is wrong, I guess. Strategy. Okay, it should be something like strategy. Which line that was? So this line was 42. Line number 42. Okay, so here also the spelling was correct. Simple imputer. And here I just have to use strategy. Okay, now I think it will work. So it is necessary that you have this custom exception raised, right? So now if I go ahead and read it, everything will work fine, but still I'm getting an error. Line number 101, center cannot center sparse matrix with mean is equal to false. Instead docstring, C docstring. Okay, this is for 101 line. Let's see where it is. 101 line. Okay, no problem. I will go and see 101 line. See, this kind of errors you'll be getting over here. So guys, I got to know the error, what exactly it was. Here I had written train underscore df. This will basically be test underscore df. Okay, so just have a look onto those kind of errors. Now I think it will work fine. It looks good. I have all my saved processing objects. This is my artifact, and the preprocessor.pickle file is created finally. So yes, it is not that simple. Always you'll be getting the error. But the main thing is that how you are able to fix the error. That skill set you should definitely try to find out. Okay. So great. We have done all this modification. We have saved all the file. Now what I'm going to do, I'm going to commit this code for you all so that you can use git add dot git commit -m. Okay. Here I will just say data transformation is added. Data transformation done. Saved it. And then I can say git push -u origin to main. So once I do this, all my push will happen. And finally, I'll be able to see in the GitHub link. The GitHub link will be given in the description of this particular video. So guys, this was it from my side. We did each and everything in an amazing way. We found out all the data transformation technique, everything as such. What all things we specifically did, we transformed our data set, we handled the categorical values, we handled the missing values. And here I've just shown you by writing line by line code so that you'll be able to understand. So yes, this was it from my side. I will see you all in the next video. Thank you.